Chapter 5, Lesson 1, Lines. You will be able to identify relationships of angles formed by two parallel lines cut by a transversal. There's a lot of vocabulary in this section, but once you get used to it, it's not so bad. A line that intersects two or more lines is called a transversal. So in this example here, I have two lines that are parallel, indicated by these pink arrows. Line L is the transversal because it cuts the lines. And because of it, we have 8 angles that are formed. Interior angles lie inside the lines. So here are our lines right here. The interior angles are the ones inside those two lines. So 3, 4, 5, and 6 are inside those two yellow lines. So those we call interior angles. Exterior angles are the angles that lie outside of those lines. So if these 4 are inside, these 4 are outside. Therefore, they are exterior. Interior, inside, exterior, outside. Okay. Alternate interior angles, well, they're interior angles, which means they're on the inside, and they're alternate angles, so they're on opposite sides of this transversal. So, for example, 4 and 6 are alternate interior angles. And then let me do some erasing here. So 4 and 6 are alternate interior angles, and 5 and 3 are alternate interior angles. And it's important to know that the alternate interior angles are equal to each other. They're the same measure. So then alternate exterior are the exterior lines on alternating sides of your transversal. So 2 is alternate exterior to 8, and those are also equal, as well as 1 alternate exterior to 7, and those again are also equal. Okay. Corresponding are those angles that have the same position on the two lines in relation to the transversal, when the lines are parallel and their measures are equal. Examples. So let me erase again. Okay. Angle 1, if I were to cut this diagram in half, cut it in half here, and then move this top section down, 1 would match up with 5. Those are corresponding. Similarly, 4 would match up with 8, 2 would match up with 6, and 3 would match up with 7. Note that they're in the same position of the intersection. So if I'm looking at just this top intersection, these 4 angles, angle 1 is in the top left, and so is angle 5. Angle 2 is in the top right, and so is angle 6. 4 is in the bottom left, so is 8. 3 is in the bottom right, so is 7. They're corresponding. Now, a couple other things. The red right angle here indicates that lines M and N form a right angle, which means they are what we call perpendicular. And here's the symbol for perpendicular. These arrows here represent that lines are parallel. Okay, so a box represents perpendicular. The arrows on top of those lines represent parallel, just like they are in this upper diagram. Those arrows represent that they are parallel. Okay, let's do some examples here to help us get a better understanding. All right, classify each pair of angles in the figure as alternate interior, alternate exterior, or corresponding. So angle 1 and angle 7. The first thing I'm going to do, and let me erase that. Well, we'll do this. The angle 1 and angle 7. Okay. Now, they're both on the outside of my parallel lines, and I'll highlight those parallel lines for you. Oops. So angle 1 and angle 7 are both on the outside. They are also on alternating sides of the transversal. Therefore, we call these alternate exterior. Angle 2 and angle 6. Well, 1's an exterior angle. It's on the outside of those parallel lines. And 6 is on the inside. So I know they can't be exterior or interior angles. So then I'm going to look, are they in the same position of the intersection? Well, 2 is on the top right, and 6 is on the top right. So yes, they're the same position, which means they are corresponding. Angle 4 and angle 6. Here's 4, here's 6. They're both on the inside of those parallel lines, and they are alternating the transversal. Therefore, they are alternate interior angles. Angle 3 and angle 5. They are both on the inside of those parallel lines, and they alternate the transversal. Therefore, again, they are alternate interior. Four and 8. They are on the same side of that transversal, and one's on the inside, the 4 is, 8's on the outside, so they're not alternating, they're not in both interior or both exterior, but if you look, they're both on the same, in the same position of their respective intersections. So therefore, they are corresponding. Find missing angle measures. Now remember, alternate exterior, alternate interior, and corresponding angles, they're all congruent. They're equal. They have equal measures. So when two parallel lines are cut by a transversal, special angle relationships exist. If you know the measure of one of the angles, you can find the measures of all of the angles. Suppose you know that the measure of angle 1 in this diagram is 50 degrees. You can use that to find the measures of angle 2, 3, and 4. Okay? Angle 1 and angle 2 are supplementary because they form a straight angle, which is 180 degrees. So I could then say if angle 1 is 50, and 50 plus something gives me 180, that would be 130 degrees. And again, the reason because 1 and 2 are supplementary. Now, angle 3 is 50 degrees because angle 1 is 50 degrees, and they are vertical angles. They are across from each other, which means they are also congruent. And the same, a couple reasons for angle 4. It's also supplementary to 1, or again, it's vertical to 2. Vertical angles and supplementary angles are a review from 7th grade. I'll just refresh you again once more. Vertical angles are across from each other at an intersection. So 4 and 2 are vertical, 3 and 1 are vertical, 6 and 8 are vertical, 5 and 7 are vertical, and they're also equal. And supplementary means they add up to 180, they form a straight line. So 1 and 2 are supplementary, 2 and 3, 3 and 4, 4 and 1, similarly. 5 and 6, 6 and 7, 7 and 8, 8 and 5. Those are all pairs of supplementary angles. We can use all of these relationships to find missing measures. A furniture designer built the bookcase shown. Line A is parallel to line B. If measure of angle 2 equals 105, so 105 degrees, okay, find the measure of angle 6 and the measure of angle 3 and justify your answer. Okay, so we want to find angle 6 and angle 3. Well, let's look at the information they gave us. They gave us the measure of angle 2, which is 105 degrees. I can use that to find the measure of angle 6. I know that angle 2 and angle 6 are supplementary, which means they add to 180. So 180 minus 105 is 75. So the measure of angle 6 equals 75. And my justification, it's supplementary to angle 2. Okay, that's the first one. So this one I know now is 75 degrees. I also know that angle 6 and 3, they are alternating the transversal, and they're both inside the parallel lines. So that tells me they are alternate interior angles, and that they are also the same. So I would say that angle 3, measure of angle 3 equals 75 degrees. And because it is alternate interior to angle 6. Using the same diagram, we want to find the measure of angle 4. And there could be more than one answer, more than one justification, but I'm going to use this right here. Angle 4 is in the same position of the intersection as our angle 2, which tells me they are corresponding. So I'm going to say that the measure of, the measure of angle 4 is 105, the same as angle 2, because it is corresponding. To angle 2. In the figure, line M is parallel to line N, and Q is perpendicular to line P. If the measure of angle 1 is 40, what is the measure of angle 7? So we have a lot going on here. First thing, I'm going to label this 40 degrees. In fact, I'm going to label a bunch of stuff. So here we go, a bunch of angles to help us get to 7. If you don't know how to get from angle 1 to angle 7 right away, then just start finding all the angle measures you can. So I have this intersection right here, okay, which tells me that angle 9 is vertical to angle 4 or angle 1, therefore angle 9 is 40 degrees. I know that angle 8 is 90 degrees because it's a right angle. And I know that angle 3 here is 40 degrees because it's corresponding to angle 1. And I could keep going, but I think I have enough information to figure out 7. I know that angle 3 is 40. I know that angle 8 is 90. and I need to find angle 7. Now take a look and see that these three angles add up to 180 degrees. They do form a straight line. So let's add our 90 degree for angle 8 and our 40 degree for angle 3. And we get 130. And to figure out angle 7, we subtract it from 180 degrees. And we get the measure of angle 7 equals 50 degrees.